Time for your daily dose of automotive news. Grab your coffee, tea, or whatever snack gets you going, and let's dive into what's driving the world today.
Imagine a motor small enough to slip where old hardware never fit, yet strong enough to rewrite what electric performance feels like. That isn't vapor. Mercedes-AMG just proved it on a track most car companies only dream about, throwing 3 compact axial-flux motors into a wild prototype and running the kind of endurance that leaves marketing fluff at the gate. Records fell, engineers smiled, and a quiet British skunkworks YASA suddenly looks like the most important name you're about to hear in every EV argument. But here's the twist. This wasn't a single headline stunt. It was the latest move in a plan that started years ago when Mercedes didn't shout they bought. They folded YASA into the family, kept the brain trust in Oxford, and let them build the sort of motor you can't just scale by throwing more magnets at a cylinder. The goal? Real gains in power density, weight, and packaging. And now execs are publicly pointing at those gains, about triple the power density, roughly 1/3 the weight and space like their standard talking points, because soon they will be. The quiet master plan. Revolutions in cars rarely look like revolutions. They look like purchase orders, non-disclosure agreements, and a new badge on the building at the edge of town. In July 2021, Mercedes-Benz acquired YASA outright and didn't smother it with bureaucracy. They left it to do what a great lab does, solve for physics with elegant engineering. Oxford kept humming. The focus narrowed to axial-flux machines with ridiculous power density, the kind of package a designer loves and a manufacturing chief quietly fears. If you're wondering whether this was a press release strategy or a production strategy, look at the factory timeline. YASA opened an upgraded Yarton facility in May 2025 to push capacity north of 25,000 motors per year. That scale matters. It's a signal that this technology is moving from cool lab demo to we're actually going to build a lot of these. And at Mercedes' Marienfelde site, axial flux manufacturing means inventing the assembly line almost from scratch, about 100 production processes. T-Max 65 entirely new because making a flat yokeless segmented armature machine is not remotely the same as building another cylindrical motor. The disk that bends physics. Here's the simplest way to picture it. Most EV motors are like a roll of paper towels spinning around a tube. Radial flux. YASA's is more like a pair of compact disks facing each other. Axial flux. That geometry shrinks the magnetic path, concentrates the action, and lets engineers chase power density without carrying a gym's worth of iron. The result? Meaningful weight cuts, tighter packaging, and in the right design, efficiency gains that don't get thrown away as heat. It's the same electricity and magnets, but arranged so that every millimeter works harder. Why should you care? Because weight and space are taxes. Reduce both, and suddenly a car can carry the same punch with a smaller battery, or carry more battery in the same space, or just be lighter, which helps everything ride, handling, range, cost targets. Execs at AMG have started speaking plainly about it. 3 quint power density, weight/space versus the familiar radial flux machines most EVs use. These aren't little deltas, they are layout-changing numbers. Track proof, not press releases. Now the part that separates sizzle from steak, track data. At Italy's Nardo, the AMG GT execs concept circled at an average you rarely say out loud 300 km/h and knocked down a list of EV endurance feats. One of those grabbed headlines, effectively around the world, in just over 7 days, 13 hours on a 12.6-kilometer ring, backed by brutal 24-hour totals over 3,400 miles. This wasn't a science fair with a tailwind. This was punishment. Fast laps, punishing charge cycles, rotating drivers, real tires. It was also a showcase. 3 axial flux motors, 800-volt hardware, liquid-cooled cells, and the confidence to invite the stopwatch. Does that mean your driveway gets an AMG spaceship tomorrow? No. It means the physics works at speed, under load, across days. It means software, thermal management, and charging strategy are now part of the same conversation as the motor itself. And it means the disk motor isn't just a brochure graphic, it's a powertrain that can handle blistering use without melting the margins. Ferrari's clue and prototype hype. If you want a sanity check, follow the customers who bet early. Ferrari put YASA axial flux machines into its flagship hybrids, SF90, later the 296 GTB, not because they needed a trend, but because compact torque packaged beautifully with a V6 V8. That's the no-nonsense validation. When Maranello bolts your motor into a supercar, you've proven something beyond computer plots. As for the viral engineering demos, yes, you've seen the eye-popping headline, a YASA axial flux prototype touting absurd output per kilogram. Think race-grade specific power in a unit you could carry if it were safe to do so. Those numbers live in prototype land, not showroom order guides, but they show the ceiling is high. The floor is already here, in cars you can actually buy. The Tesla stock BY, Toyota question. This is where the internet goes to war. Does axial flux dethrone Tesla? Does it box out BYD? Does it force Toyota to rethink hydrogen? Here's the honest picture. Tesla's superpower has been battery integration, software, and relentless iteration on motors that are already among the world's best mass-market units. But the form factor and physics of axial flux are different enough that, if Mercedes can scale it, the conversation shifts. It's no longer just who has the slickest cell chemistry. It becomes who extracts the most car out of a given kilogram. Reports claim several rivals are evaluating axial flux for niche performance variants. Rumors suggest some are modeling cost-benefit versus mature radial platforms before committing. In short, nobody sleeps on triple-density claims. BYD, with its blade battery edge and vertical integration, doesn't lose overnight. Yet if production axial flux lets a competitor match range with fewer cells or beat performance with less mass, BYD's cost calculus changes. It's leverage either way. You can go lighter, or you can add range without inflating the package. That pressures any incumbent leaning mainly on battery leadership. Toyota, the company that practically invented hybrid reliability, is already hedging across hybrids, BEVs, and hydrogen. If axial flux motors filter from AMG down into premium mainstream Mercedes models, Toyota confronts a different customer question. Not is hydrogen cool, but why is this rival lighter, smaller, and quicker with similar range? If the market starts asking for disc motor packaging plus real-world gains, strategy meetings get noisier. What could break this? Let's be adults about the hard parts. Manufacturing axial flux machines at scale isn't just swapping a stator and calling it a day. Mercedes' own disclosures around the Marienfelde line talk about M100 production processes with dozens brand new. A reminder that yield, quality, and cost curves have to be bent by investment and time. That's before you confront supply chains for magnets, the metrology needed for sub-millimeter tolerances, and the training required for a workforce raised on radial architecture. It's doable, it's just not trivial. Cost is the other governor. Hand-built motors look heroic in slides. They look scary on a P&L. That's why the Yarton Superfactory matters. 25K plus units/year is not Model 3 volume, but it's not 5 for press cars either. It's the scale that lets learning kick in, and part costs start heading south. Until then, axial flux leaves first, where the margin can bear it. AMG, Halo products and eye-opening demonstrators that make the mainstream want what the poster car has. Track to showroom, the next 24 months. So when do regular humans touch this? The AMG GT execs concept wasn't a tease without a plan. AMG leadership is already talking about bringing axial flux to more models, starting with the performance-heavy AMG EA platform. Pair that with the recent record program and you have a near-term on-ramp. First the flagships, then a careful cascade. It's the same playbook AMG used when it turned a burly V8 into a brand signature across segments, only this time the engine is a flat disc with an appetite for volts. And don't miss the supporting cast. The Nardo run leaned on oil-cooled cylindrical cells, 800-volt architecture, and megawatt-class charging rigs custom-built for punishment. Translation: Mercedes isn't betting the farm on a single trick. It's stacking complementary tech so the motor's advantages aren't strangled by thermal limits or slow juice. That kind of systems thinking is how you turn a lab darling into a product line. Your mental model upgraded. When you evaluate EVs over the next few years, add a new question to the usual battery/range price set. What motor topology is it using? And how is the car packaged around it? If it's axial flux, ask how the automaker spent the weight/space savings. Did they shrink the battery and hold range, saving cost? Did they hold the battery and extend range? Did they repurpose the packaging for cabin volume, frunk capacity, or aero tricks? The right answer will vary by model, but the point is the same. Axial flux creates new trade space. Smart teams will use it to differentiate. What this means for you and the market. Investors chase curve-bending tech. Customers reward products that feel better the second they roll. Engineers want architectures that scale. Axial flux checks all three boxes if and only if factories, suppliers, and cost curves cooperate. The recent demos, the factory upgrades, and the executive language all point the same way. This isn't a side quest. It's an idea with momentum, now breathing real track air and moving toward real roads. The bet you're making. If you believe the future of EVs is the same but bigger batteries, you'll miss why designers get wide-eyed talking about a motor that frees space like a magician and shreds weight like a race engineer. If you believe software alone wins, you'll miss how hardware shifts the ceiling. And if you think nobody will catch the incumbents, remember how quickly the conversation changes when one company shows a car that's lighter, smaller, quicker, and stays quick lap after lap. Reports claim rivals are already prototyping disc motor variants. Rumors suggest supplier scouting is quietly picking up speed. Whether those programs ship is a separate story, but the fact they exist tells you enough. The physics is persuasive, the demos are persuasive, and the first automaker to bridge cost and scale will set the next baseline. So is Mercedes-AMG's YASA Flux era a footnote or the new table of contents? The records say the motor can take a beating. The factories say the company intends to build a lot more. And the packaging freedom says we're about to see EVs that don't just add range, they rearrange how the car is put together. Watch the next 2 model years. They're going to decide which brands set the pace, and which ones start asking awkward questions in boardrooms. If you want deep dives like this, minus the fluff, stick around. More under-the-skin stories are coming. Drop a like and subscribe so we can cross 100 subs. You're part of the first 100. See you on the next video.